Oh, hey. Just checking out this atlas. Have you ever wondered how we know that the Earth is curved? My name is George, and today I'm going to explain to you how you, in your backyard, with the help of a friend, can measure the curvature of the Earth. So how do we know the Earth is curved? Well, for one, people have traveled around it before, and you could even travel around it if you bought the right series of plane tickets. Number two, we've been to space and we've seen the whole Earth, and it is indeed round. Number three, on a long list of reasons, is that gravity exists. We know that gravity pulls things together, so we expect that it would be very unlikely that the whole world exists very flat, because gravity would tend to pull it together into a round ball. But how did we first find out the Earth was curved? Well, for that, we'll need to tell a story about an old Greek fellow named Eratosthenes. Eratosthenes lived around the year 200 BC in the ancient Egyptian city of Alexandria, which is at the mouth of the Nile at the furthest north part of Egypt. He was a mathematician, a poet, a philosopher, and was the chief librarian of the Library of Alexandria, where most of human knowledge at that point in the world was housed. For a man who couldn't travel very far, since the only possibilities were by camel or by foot, he drew incredibly detailed maps of the Mediterranean and the rest of the world. One day in the library, he read the story of a town south of Alexandria on the Nile, a town called Cyrene. In this story, travelers reported that on a certain day of the year, the sun shone directly down to the bottom of a well, illuminating the entire well. But Eratosthenes realized that on the same day in Alexandria, in the plaza outside his home, a great statue cast a shadow. How is this possible? Eratosthenes asked himself. How can the sun cast different shadows at different places on the surface of the Earth? The only explanation, he reasoned, was that the surface of the Earth was curved. The crucial idea of Eratosthenes was that on a curved surface, objects of the same height will cast different shadows at different places. Can we test this? Well, let's see. I've put two toilet paper rolls on the table, and you can see that even at different locations on a flat surface, they cast roughly equal shadows. This is what we'd expect if the Earth were flat. Now I've put the two toilet paper rolls on a curved surface, and you can see that at an even shorter distance apart, they cast vastly different shadows. This is what Eratosthenes saw. You can do this too. You just need a measuring tape, and an empty roll of toilet paper or paper towels, and a smartphone. Actually, that's not all you'll need. You'll also need a friend or relative who lives some relatively large distance away from you. And you'll need them to have an empty toilet paper roll and a measurement device also. Then the experiment is simple. You choose a specific day and a specific time. You take your toilet paper rolls outside, place them on a level surface, and each measure the length of the shadow that's cast by your toilet paper roll. If the shadows are different, that right there is your proof that the Earth is curved. Now, if you'd like, you can take it one step further, like Eratosthenes did. Eratosthenes measured the length of the shadow in Alexandria on the day that he knew the sun shone directly down into the well in Cyrene, casting no shadows. Then he paid someone to walk all the way from Alexandria to Cyrene in order to measure accurately the distance between these two cities. Using that and the lengths of the shadows that he'd measured, Eratosthenes was able to determine the curvature of the Earth, to determine the circumference of the Earth, with an accuracy that was incredible given the time at which he made his measurements. I did this experiment when I was in Santa Barbara, and my dad was up in San Francisco. So we each took a measurement at the same time on the same day, and we found, indeed, different shadows. Even beyond that, using a little bit of math, we were able to determine that by our measurements, the Earth should have a circumference of around 29,000 miles, which is only 4,000 miles off the exact answer. You can and should try this experiment at home. And if you'd like to learn a little bit about how you can use your measurements to gain an estimate for the circumference of the Earth, you can check out the Google document that I wrote up that includes the math and even how to figure out the math. So with that, I wish you happy experimenting and good luck proving the flat earthers wrong.